So in this video, we're going to talk about the limit of a function. And when we talk about limits, we want to look at the behavior of what the graph is doing around a specified x value. And we need to look at that from both sides. So first, we'll start with the left-hand side. We're just going to take values closer and closer to 0 and evaluate the function at those values. So I have negative 0.1, negative 0.01, and negative 0.001. I just plugged these into my calculator, and as you can see, we could say as x gets closer to 0, f of x gets closer to 1. Now, same thing for the right-hand side. I think it ends up being the same on each side for this one, but it is possible for it to be a different value on each side. But they're the same, so we can say as x approaches 0, f of x approaches 1, since it's the same on both sides. Next, we're going to talk about evaluating limits by looking at the graph. Here we have the function x squared. So we want to see what is the function doing as x approaches 0 from each side, also known as the limit as x approaches 0 of x squared. So if you look at the graph here, you can see that as x approaches 0, f of x also approaches 0, and it's the same on both sides of the graph, both sides of 0. Alright, so now we're going to look at one-sided limits. As you can see, this one's a little different on each side, so we have to break it up into two different limits from each side. So in this case, both limits are actually the same, but the function takes a different way of getting there each time. Sometimes it's not the same on both sides. So we're going to look at infinite limits here, and this one is not going to be the same on both sides. So this is the limit as x approaches 0 of 1 over x, and we're going to have to break it up into two limits. So we have from the negative side and from the positive side. Evaluating each of these, you can see it's not the same value on each side. Since the values are not the same, well, first of all, from the negative side, it equals negative infinity, positive side, it equals infinity. Since these values are not equal, we can say that the limit as x approaches 0 of 1 over x does not exist. Alright, now we're going to go over a simplified way of evaluating the limit of a function. You can actually just evaluate the function at the value that we're taking the limit at. This doesn't work in every single case, but for most cases it does. So here I just plugged in 2 for every x, and it's simplified to 2/5. Alright, so next I'm going to show that you can also simplify the function before you plug in the x value. Here I'm just going to simplify this. Before I plug in 2 for x, it simplifies to x over 2x plus 1, which also equals 2/5 when plugging in 2. So you can say that the limit as x approaches 2 of that function equals 2/5. Now we're going to try again. This one, you're actually going to have to simplify it before you can plug in the value. I don't know if you guys see the problem here, but I'll just plug in the number. We get 4 minus 4 equals 0 on the bottom. That's no good, so we're going to have to simplify this and see if we can get something other than 0 over 0. There is a different rule we'll learn for this kind of function later in calculus, but we have to learn a few more things first. This one does simplify into something else, so we're able to get the limit equals 1 for this one.